Thank you all for joining for this session, because I understand this is a last session of Spark Summit, and I hope that I share some knowledge about Apache Ignite ML library. I think that if you join this session, you're interested in alternative approaches to Spark ML, and this talk will be concentrated on yet another distributed ML library, which can be used with Spark together. Okay, let's start. I am Alexey Zinovyev, and as was said, I'm flying from the opposite side of the Earth, and my native time is 4 a.m. But it's a very deep night, but I'm trying to talk with you about Apache Ignite. I'm Java developer, first of all, and most of content today and snippets of code will be written in Java. I'm sorry for Python developers. I will talk about a little bit about Python later. I am a distributed ML enthusiast and Apache Ignite committer. And I also am happy father and husband who sponsor this tour to United States with many time. I wanted to visit this summit for a few years. I'm using Spark for 5 years. I don't remember exactly the version from what version I started my using of Spark. And Spark ML was my first experience with Spark. It hadn't pipeline that time when I used. The API was based in RDD blocks. I think most of you remember that. And also, let's go together through the different MLDL popular frameworks. I think you know most of them. We can see Apache Mahout. Maybe somebody remember that framework at the top of the Hadoop. I've worked with that. I think all of you know TensorFlow. Maybe somebody here about DL4j. It's a Java library to create a different neural network architecture to join with Spark, for example, scikit-learn, of course, PyTorch, Keras, and etc. And what's the reason to add yet another library here? Let's start from the Python. If you have petabytes of data, then the Python libraries like scikit-learn, I really like scikit-learn, but it will not be able to process even a small fraction of the data for building a machine learning model. For example, if you have 1 terabyte, for example. Spark ML is a good answer on this question. Spark incorporates a truly remarkable set of classical machine learning algorithms, and that allow us to perform iterative calculation on data in memory, right? But what is bad with Spark ML? I know that this is the last session and can say something about Spark ML. I wanted to say that Spark ML is bad. But something going wrong with Spark ML. First of all, it doesn't support our common approach of building modern ensembles as stacking, boosting, and bagging. Of course, we could find gradient-boosted trees and random forests, but it's very small movement in this area. Also, it doesn't support online learning for all algorithms. It supports only a few models like linear regression and k-means and streaming mode. I mean, then I talk about online learning, I mean that we should have ability to join 2 models, for example, in streaming mode with structured streaming, maybe with old day streams, but we have no this ability in Spark. Maybe you could find something in Spark packages, but I'm not sure. Also, it has a lot of data transformation overhead from data source presented in Parquet, for example, to labeled vectors internally in different ML algorithms. It has hard integration with TensorFlow Cafe. You could find on the GitHub different projects like one project from Yahoo, TensorFlow on Spark, and etc. Today, we could hear the good talk about Spark, Harvard, TensorFlow integration, but you can understand how long this chain. Also, that's not all. Part of algorithms are using sparse matrix. I hate sparse matrix because matrix computation like multiplication can be easily parallelized, of course, but many matrix operations are not easy to implement in distributed version. You should have all matrix on all nodes of your computing cluster. That's bad. Also, you could find in Spark ML several unfinished approaches of model inference, model serving. I found one great Google Doc where Databricks and other Spark developers discussed a few years ago how we should save models from Spark. Maybe via PMML library, maybe somebody used it, maybe via GPMML library, via saving to Parquet file, how it implemented now. Maybe you should use MLeap or MLflow. There are a lot of different approaches, and part of them are not finished. For example, saving to easy readable PML format, which can be understandable via scikit-learn, etc. It doesn't support AutoML algorithms for hyperparameter tuning. I mean, not only grid search, how it's implemented in pipelines, but really smart hyperparameter tuning. And ML algorithms internally uses MLeap, which should be deprecated, of course, but it doesn't rewritten totally on data frames, right? If you will open the code of different ML algorithms, you will see how it translated to MLeap calls. And the main problem with Spark ML, from my perspective, I've tried to prepare a lot of different PRs to Spark ML. You grow old before your PR will be merged. Unfortunately, yes, it's a very huge problem with Spark. You need years to add a reasonable feature. If you are not Spark, I don't know, PMC, you have no chance, in my opinion. And this is a bad thing with Apache Spark ML. For me as an active user of Apache Spark, I want to add new features. I want to take new features from distributed machine learning today, yesterday, I don't know, 2 days ago, but not in the unclear future. And this is the reason why I joined to Apache Ignite community. I understand that maybe you don't know what is Apache Ignite, but this is another Apache project under Apache license, of course. This is like of in-memory SQL database. It supports SQL. Internally, it uses different Java cache-like structures and etc. And 1 year ago, the ML module under Apache Ignite was started. Apache Ignite can be used as a backend, for example, for Apache Spark 2. You can use special memory structures to speed up RDDs, data frames, and etc. For example, in Stack Overflow on Apache Ignite dev list, you can find a lot of examples how to use they both together. I mean, Apache Ignite as database or as a backend for speed up of Apache Spark. But I'm trying to explain what is an Apache Ignite ML model and how it used together with Spark. There is now so many ways, but let's start. First of all, we want to set up Apache Ignite cluster near the Spark cluster to train on Spark data. All data, first of all, located in Apache Spark, in Parquet, in Hive, I don't know, in maybe as a result of transformation processing, as you wish. And Spark can act as one of data source for Apache Ignite ML. I will have a lot of kind of architecture diagram of different applications with pseudo symbols. And let's start from the very simple example. And trained data should be loaded in Ignite in memory caches from Spark data frames. And we have several ways to do that. This special form of write operator in Spark. You know this data frame, write, mode, and etc. I think most of you use that. Or if you want to control loading of each k-value pair, please use a special subclass of CacheStore. CacheStore is special interface in Apache Ignite to implement different data sources like JDBC, oriented databases like PostgreSQL, Oracle, etc. The first approach via write.format Ignite. Out of box, Spark doesn't know about Ignite, of course. So we have to start with a couple of extra parameters. For example, we could run PySpark with Ignite jars. Next, we should load the data into a Spark data frame. For example, here we read something from JSON file. It can be passenger from Titanic dataset. You can do any manipulation you like at this point, adding or removing columns, computing new values, etc. All preprocessing can be did in the Spark. And after that, we should write it out to Ignite. Here, you can find another approach, the implementation of CacheStore. This is an interface in Ignite that gives us a basic set of operations which you should implement. If you know Java, if you know Java syntax, it will be easier. You should implement a lot of methods and define functions how to extract data from data frame row to Ignite cache value. We should export data frame rows to Ignite cache. OK, let's continue. Also, for training, Apache Ignite supports kind of partition-based datasets. It reminds me RDD in Spark with basic functionality, but with another internal representation based on Apache Ignite caches. Also, the current release supports a lot of algorithms, and I think that in release 2.7, we have a parity in algorithms with Apache Spark. But the release 2.7 was a few months ago. You can download our master branch to build this and use new algorithms too. I will talk about our next release, which will be published in a few weeks, I hope. But you can find all these algorithms in master branch today, as I said. Currently, the framework contains enough implementation of classical algorithms. You could find here logistic regression, SVM, decision trees, random forest, and kind of approximate nearest neighborhood. This is improvement of KNN, which could avoid us loading of all neighborhoods from training phase to the prediction phase. It has very good approximity, good distributed implementation, and effectiveness of KNN. Also, it supports regression algorithms, different decision tree regression, random forest, gradient boosted tree regression. We should know that new algorithms could be added very easily here. Of course, we could not avoid a gentleman set with neural networks. We have implementation of multilayer Perceptron. It has many hyperparameters which can be tuned via hyperparameter tuning grid. And let's build the model. How to train the model on the given Ignite cache or Ignite SQL table loaded from Spark. It's very easy. We load this via CacheStore, for example. After that, we create a data cache. We should build something like a vectorizer. It reminds me vector assembler, where we should pass as a parameters indexes of elements in array or a different interval structure, index of label, to build special internal vectors to train on them. After that, we could define the trainer and feed the trainer to the data cache. Also, we should evaluate our model. We couldn't avoid that. For example, if you need to calculate the classification metrics, accuracy, for example, and different classification metrics, you could use evaluator to evaluate something. It has a state, it's like a pure functions. Of course, the sun will die before we implement all the algorithms of scikit-learn, but we could try. The amount of preprocessor could be compared with Spark, except the NLP preprocessor. We haven't something like stop words remover and etc. It's a separate task, and currently the NLP techniques are not supported. We are trying to integrate this with Open NLP library. Of course, it has different scaling preprocessor, a lot of them. One-hot encoding, you know that. And the code with preprocessing looks like this. The Java code with intermediate data transformation is presented here on the slide. All preprocessors are lazy and are functions by nature that takes Ignite cache, parent preprocessor, to build the chain and makes labeled vector with transformed by this function data. Also, sometimes, it's difficult to evaluate how good this or that binary classification model, and Apache Ignite, of course, supports different versions of cross-validation, not only k-fold cross-validation, how it implemented in Spark, but different, how it's implemented in scikit-learn. Of course, we could build a pipeline, whole pipeline. I think each ML developer wants to avoid noisy fit method call. And the idea of scikit-learn and Spark pipelines is implemented in Ignite 2. If you know that Spark ML pipelines were copied from scikit-learn pipelines, I read about that. And on this slide, you could see the whole pipeline in Apache Ignite. You could add preprocessing trainer, a lot of them if you need. Final trainer, for example, here, decision tree classification trainer, adds cross-validation like a scoring, different values of parameter grid. And in this slide, we're trying to combine together pipeline data, classification metrics, hyperparameters tuning, and cross-validation to get the best model. At this point, you can see that Ignite and Spark has the parity in classic ML, in the API, and etc. It can be used without, I don't know, big knowledge gap, with not so many time to switch your code from Spark to Ignite, but this is not all. Ensemble methods were added in Apache Ignite a few months ago. There are method algorithms that combine several machine learning techniques into one predictive model. In order to decrease variance, is by bagging, bias is by boosting, or improve predictions by staking. Let's look at one of them, staking. All of them are supported in Apache Ignite, but I'd like staking because it was implemented by myself. Staking involves training a learning algorithm to combine the predictions of several other learning algorithms. First, all of the other algorithms are trained using the available data. This is the first step. Then a combiner algorithm, here it's logistic regression, is trained to make a final prediction, using all the predictions of the other algorithms like an input. Here you can see how two decision trees at the first level and a logistic regression model on the second level could be used together by the staking API to build special staking model to predict something like each other model in the first level or in the second level. You could add more levels and combine it in more complex way, of course, but I think we have no time to light all these approaches. Also, my heartbreak about Spark ML, this is online learning. As I said, Spark supports merging of two models only for a few old models in MLeap. Then the started the development of Apache Ignite, we keep in mind this ability to add online machine learning, and in each algorithm we should implement interface update method. We couldn't add new algorithm without implementing online learning for this kind of model. And currently all the models are supporting the merging of two models or the chain of models if you want, but in the current version without weights. I think that in the future it will be added, but currently you should do it manually. But we can merge two models like, I don't know, 2 packets of milk. And in these techniques, of course, you could use Spark, train model there, load the model to Apache Ignite. I will talk a little bit later about inference the Apache Spark. You could train on your batches of data which can be loaded from Apache Kafka Apache Ignite has a good Kafka data streamer to load data from Apache Kafka, train on this portion of data and merge all the models into one by special law, which is implemented internally in our library. Of course, you could define your law by your hands, but up to you. Also, for example, on this slide, you could see an example of updating original KNN model. I know that Spark doesn't support KNN model, and people hate this because it works not very good on the big data, but maybe we have a small data to run the KNN. I understand. It's only for this slide. We have our KNN model which was fitted from the data cache, this special set of parameters. We train another model, and we could update our previous model, model 1, with new portion of data, with new data which was loaded into another cache using the same vectorizer. For example, model 2, this is updated model. Also, Apache Ignite has from the start the integration, close cooperation with TensorFlow, and I'm very honest to say that our Apache Ignite dataset was contributed to TensorFlow by developer Anton Dmitriev. Now it's part of TensorFlow contrib package. You can download Anaconda and push something into Ignite cluster if you have Ignite cluster, and use Apache Ignite as a distributed backend for TensorFlow calculation, not via Harabot. You can use Apache Ignite directly. This is a special tool set. I will talk about it a little bit more. First of all, it has Ignite dataset that provides ability to feed training data from Apache Ignite and train on them in TensorFlow directly. Also, it supports, for example, I'm not sure if you see on this slide, example of Python code with TensorFlow, where you can connect to Ignite dataset and grab data from there, and for example, to print them in TensorFlow session. Also, it supports distributed training mode, as I said. And the main idea behind the distributed neural network training is the ability to calculate gradients of loss function, squares of the errors, for example, on every partition of data in terms of horizontal partitioning, of course, and then sum them on the reducer phase. I think it's stable version. It's merged to TensorFlow a few months ago, and I think in TensorFlow 2.0 it will be available too. Ignite cluster for TensorFlow, like Yarn for Spark. It's like a simple cluster manager for backend training, etc. You should think about that in terms of cluster manager, I think. Of course, you could use your typical TensorFlow instruments like TensorFlow board, etc. Also, yet one question which is very interesting: how to work with model which was trained in another system by another frameworks. This is question of model inference support. Inference is an important part of machine learning in production, of course, and Apache Ignite supports inference from TensorFlow, from Spark via different approaches. This is a direct parsing of Spark Parquet files, which was getting by write method, you know, model save to Parquet file from this method via prediction on MLeap runtime. Also, Apache Ignite has XGBoost model parser, and I think that in future we will add more for MXNet, for PyTorch, and etc. How it can be used with MLeap system? We experiment with different model inference, so we don't know what would be final decision. This example demonstrates how to import MLeap model and use imported model for distributed inference in Apache Ignite. 8 here is number of service instances maintaining to make distributed inference. Here you could asynchronously predict something on the vector constructed from 2 values. Also, we have a Spark ML model parser. As I said, you could train something in Apache Spark, get the model, save this model to Parquet file via Spark. You shouldn't get Apache Ignite here. After that, you can load it in Apache Ignite and, for example, update by the new portion of data. Train new model on Apache Ignite and merge them using online learning, which is presented in Apache Ignite. This is how it can be used. This is an example of typical Spark model pipeline. You know, very short pipeline. You first of all make vectors from data frames, columns using special vector assembler. After that, you transform data frame to vectorized data frame with dropping rows. After that, you set up the decision tree classifier, train the models, and save the model via write operator. How it can be used in Apache Ignite? You could load this data, new portion of data from data cache, define the vectorizer, parse the data via the path to the file. Also, you should choose one of supported model, but currently we support all Spark models. You know, the set of Spark models isn't changed from time to time. It's very easy to support all versions. And of course, you could evaluate new model, or maybe you can use online learning or something else. I think maybe after this session, you will return to home and maybe next week somebody download the Apache Ignite and trying to build your own application with Apache Spark, Apache Kafka, Apache Ignite, train a lot of models, merge them in Apache Ignite and predict something and maybe add something from XGBoost and etc. You know how it can be cool. I hope. As I said, Apache Ignite had a lot of connectors and can be your own in-memory database, which can get a lot of data from different data sources, and Apache Spark can be one of these sources. Of course, please reduce the data because it's in-memory database and we couldn't spill something on disk, but it can be fast. Also, the small roadmap. If you're interested in Apache Ignite ML after my talk, give me a few seconds to light the roadmap. We are planning next features, and the next release is NLP support, Spark pipeline inference support. Currently, it parses only Spark models, but not the whole pipeline. Whole pipeline are supported via MLeap. Also, we hope to add DL4j integration to support another Java developers who are trying to do this Spark and generate a lot of Spark tasks here. And I'm trying to add more approximate ML algorithms like ANN, the approximate version of KNN, which could be more faster than current implementation, which are not approximate. But I hope that we can keep the accuracy of these algorithms and where can be used in the distributed nature. Also, in conclusion, Apache Spark and Apache Ignite could work together. I hope they are friends. Apache Ignite ML is a son of Apache Spark ML. First of all, we learn a lot from Spark ML algorithms sources, and we are trying to find faults and maybe incorrect decisions and re-implement it correctly in Apache Ignite. I hope that we did it. New features and capabilities of distributed ML learning could be a reason to taste Ignite ML, I hope. And you could load Spark models to Ignite and continue your work with them via online learning algorithms and etc. And it's very easy to add new feature to Apache Ignite ML. You could write me. I'm Apache Ignite committer. I could help to create your ticket in Apache Ignite Jira to become a contributor. Let's discuss something in Apache Ignite developer list or user list if you need more functions in Apache Ignite ML library. OK, you are welcome. And don't forget to cite me as a reviewer if you created a pull request to Apache Ignite. Thank you. Thank you. If you have any question, you can ask me. We have a lot of time, I think. Or we could go to the corridor and discuss later. Thank you.